Welcome to part 2 of the regression video. I had a few technical difficulties in part 1 at the end there. Fortunately though, it cut out right as I was about to go to explaining the f-test. So in this video I will be explaining what the f-test is, what the f-distribution is, and how to use it in the context of regression. So we left off with this equation here, and what the f-test represents conceptually is how close your y hat line is to your y bar line. So if I draw out the graph here, you can see what that looks like. We can see what that looks like geometrically. So I'll just redraw the graph that I had going. Then I'll make teal as our y bar line, and we had a purple y hat line. So I'll make that y hat. Alright. Yep, and going back to the, again, this is the formula for the f-test. We take the sum of the squared errors. So essentially, if this was my point that I'm taking, then you're actually I'll draw a different point to make it clearer, maybe. So if this is the point that this is just an example point. The sum of the squared error is this distance, the error squared. Square that. You do that for every single one of these points, and you add it all together. Sum of the squared residuals is going to be this distance between your y hat line and your y bar line, squared. And again, you do that for every single point. So you do that here as well, and you square it. You do that over here, etc., etc. I'm not going to draw that in because then this is going to get really cluttered, but you get the picture. So what the f-test actually is and how it's calculated in, I guess you can say, real life, is it's a ratio between two chi-squared distribution tests adjusted for degrees of freedom. Now, the real equation for the f-distribution is beyond the scope of this video. However, if you're interested in finding out how to actually calculate it instead of using a table, you can check out the chi-squared distribution videos on Khan Academy. Or there's also a video titled ANOVA 3, also on Khan Academy. I will post both to the links. I will post both links to the description of this video. However, for the purposes of understanding what the f-test actually is, think of it as a measure of how close your y hat line is to your y bar line. Because remember, the further away your y hat line is from your y bar line, the greater the probability that you're saying that this model is a better explanation of this trend than just simply your default position, which is your y hat. So to perform the f-test, what you need to do is, first of all, once you figure out what your sum of squared errors is, your sum of squared residuals is, as well as your numerator degrees of freedom and numerator and denominator degrees of freedom, what you do is you find out whether or not this value that you calculate is going to be greater than equal to some critical value. Some critical value. Normally, if you did let's say a normal distribution or a sample from the normal distribution, you would have, you'd see alpha equals 0.05, and we'd call that your critical value. Critical value, but I'll put that in quotation marks. And the reason for that is that under your f-test, the f-distribution is such that your critical value is not simply going to be this 0.05. In fact, you're going to have to look it up in an f-table to find out what your critical value is. So I have an example of a f-table here. And the first thing you do is you select, you go to your alpha is 0.05, click on it. And then you have your, along the top, you have your numerator degrees of freedom. And along the side, you have your denominator degrees of freedom. For alpha is 0.05. And so in the table itself, you will find the critical value for which you're going to get your alpha is 0.05. And then we can measure whether or not our regression line is valid or not. So going back to the original example, our numerator degrees of freedom is just 1 because it's linear regression. And then the denominator degrees of freedom, we said that n equals 100. and then minus 2, so the denominator degrees of freedom is going to be 98. So we're just going to go down this column and scroll all the way down to 98. Yeah, so our critical value is 3.9381. So in this particular example, your critical value is going to be I'll just write 3.9. Just to make things simple, 3.9. Get orange. 3.9. So this is your. I can add one more digit. Forgot what digit it was. 3.938. I'll just write the whole thing. 3.9381. And that is your critical value for alpha equals 0.05. So what that means is simply once you do your F test and you find that it's either I shouldn't write greater than equal to, if it is less than 3.9381, what that means is that we can say with 95% confidence that this y hat is far enough from the y bar that the regression line is a more accurate model for these data than the default position, which is just the y bar line. If you'll notice from the equation, for your sum of squared errors and your sum of squared residuals, the further away your y hat line is, or the greater the slope, or you can think of it as the greater the deviation from the y bar line, the greater this number is going to be. Of course, adjusted. So again, calculating the actual F value, it's beyond the scope of this video. So again, I will post the links to the chi-squared distributions in the video description if you want to take a look at that. However, for the purposes of this video and just as a conceptual overview of what the F test actually is, it's simply measuring whether or not this y hat line is good enough of a model such that we can say that the y hat line is a better predictor of where these points lie than our default position, our null hypothesis, which is our y bar line. In the next video, I'll go through how to interpret the results from doing a regression in Excel, and how to look at both the coefficients and the outputs, and essentially how to interpret the outputs. So I'll see you guys in the next video.